Welcome everyone. Thanks for coming. We didn't have a community meetup for quite some time, I believe. But today we have good news to share, which is that Restate 1.6 is out. And I want to walk you through some of the highlights, not everything, because for that we don't have the time, but the highlights and of this release. So the 1.6 release builds on the work that we started in the 1.5 release and gives you even more control over your invocations. Makes it simpler to run Restate across different deployments and reduces operational overhead. And that's something that I will show you in the following slides. Just as an overview, so I will start by giving you this overview, like the cool new features of Restate 1.6. Then my colleagues Nik and Pavel will show you some of these features in action. I think that's going to be the exciting part. And then at the end of the day, we have a bit of time for your questions to answer them. Okay, so the high-level overview, what's coming in 1.6 is on this slide. So these 4 themes, we will go through each of them in detail, but it's not all, of course, that is included in the release. So there are plenty of smaller improvement and fixes that we won't mention. So in general, like as a one thing that you can take home is that this release touches everything from day-to-day developer experience to making your production operations easier. So let's start with the better invocation controls. That is something that, as I've said, we have already started in the 1.5 release with the restart as new feature, for example. So usually, if everything goes all right, you don't have to interfere. But sometimes your invocations fail for some reasons, and in some of them, it's actually desirable that you can like have control over them, can stop what's happening to investigate and like repair. By default, when your invocation fails, Restate will retry. But for example, if the service deployment is accidentally or on purpose decommissioned or some third-party service isn't available, then retrying wouldn't really solve the problem, because it's not like a transient or ephemeral issue that can be solved by it. So the only way to handle the situation previously was that you had to kill your invocation and thereby lose all the progress that the invocation has made. This now is no longer needed. You can now actually pause individual invocations, then investigate what's the cause of the failure, and potentially repair it, for example, by redeploying your service deployment, and then resume the invocation without losing any progress. You can even change the deployment on which the invocation should continue in case you registered the deployment under a new name. And this you can do via the CLI, the REST API, and the UI. There is one important change in the context of retrying, which is that we changed the default behavior of the retry policy from killing your invocation when it has depleted the maximum number of attempts to pausing it. This will allow you actually to now go and take a look at what's wrong and then decide what to do, whether to kill the invocation or whether to repair it. This is, actually an important behavioral change that you should be aware of. And this also manifests into like the way you configured it. Before, you configured the retry policy under worker.invoker.retry policy. And now it's under invocation.default retry policy. And again, the big change here is that when you exhausted your maximum number of attempts, the invocation will automatically be paused, not killed. Alongside that, we also changed the default number of max attempts and the max interval. If you need to, well, because you started to or got accustomed to the old behavior, you can of course get the old behavior back by setting the like on max attempts behavior to killing or to kill. But this you have to do explicitly now. So in case you didn't configure any retry policy yet, you would have to do that. You can do this like configuring the retry policies on a per surface basis, on a per handler basis, or even from an SDK. That's fine. Okay. One of the cool new features is restart from journal prefix. So as I've mentioned initially, Restate 1.5 introduced the restart as new feature. This was useful to like rerun like an invocation that they completed, like successfully or not before, but you wanted to rerun for some reason. But this always meant that you would redo all the work that has happened before, and especially if like an invocation failed, this would have meant to potentially redo some expensive work. So take, for example, this like agent with a human in the loop example where let's assume our agent is able to run a couple of iterations. And then as part of its tool choice, he reaches out to a human to approve something. And because the human was already out of office, it took a while, like to the next day. And so it's potentially an expensive operation. And now, after the approval has happened and the agent has continued, something goes wrong. You failed because the agent failed because it called like a buggy tool. So in that case, ideally, you would like to restart after, like by keeping all the successfully completed steps from before this, you called this failed tool. And with restart from prefix, this is now possible. You can basically specify the journal entry index from which you want to restart. And everything from before will be preserved. And that, yeah, that I think is a very, very useful feature, especially when your workflow, your service has like expensive individual steps. Note that to use this feature, you need to use the latest SDKs. And it's currently, you can use it from the UI or using the REST API. The CLI, on the CLI, it's not yet supported. But it's anyway nicer to use it from the UI, as you will see in Nik's demo. All right, one of the annoyances that we heard from many users was like if they managed to move many of the invocations into like a state where they needed to be killed, canceled, or purged, for example, and if they accumulated many of those invocations, it was painful to batch modify these invocations. Like before with the CLI, you could already do like cancel all invocation for the service, but it was like A, very inefficient, and B, prone to failure because it was like it would fetch all the invocations and try to cancel all of them at once, which at a certain scale would fail on the CLI side. This has now been improved by properly batching those requests and sending them over to the server, so that these operations like batch modifying invocations become a lot more efficient and feasible. And this is now actually also possible from the UI. So you can like select a couple of invocations that you would like to cancel or resume, and just trigger it from the UI, and we'll do it for many thousands invocations now, without you having to manually script around our REST endpoints. Then one of the big improvements on the observability side of things is that we now persist error events and show them in the timeline. So before, like these error events that triggered retries in your invocations were only kept in memory and also not properly displayed in the timeline. So there was no way to inspect like what has happened after like a partition failed over to a different node, for example, or after invocation completed. Now, since we store these error events, what basically triggered retries in the journal, and you can inspect them easily in the updated timeline view. And they are also part now of the sys journal table, so you can also use like the SQL introspection API to query for these error events if you like. So this is, I think, very, very nice to also like understand after an invocation completed. Was there something that I can improve? Was there like maybe an unreliability in my system somewhere? Just like more information about invocation execution is always better. And then one of the I think strong value propositions of Restate is that because of the all batteries included philosophy, you can run it anywhere, also on any cloud. But there was a little bit of fine print there, which was that for taking snapshots, that you want to be able to trim your log and to limit the replay time in case a recovery happens, you have to configure a snapshot repository. And this snapshot repository needed to be an S3, or at least offer an S3 compatible API. And so it was a bit, let's say, not super straightforward to deploy Restate on GCP or Azure with a snapshot repository. You always needed some form of an S3 compatible proxy. Now, this belongs to the past because we added native support for the Azure Blob Store and the Google Cloud Storage. So when configuring your snapshot repository, you just have to put the AZ and the GS URL schemes in front of your path and of course add your credentials that you have access, but then Restate can create snapshots and store snapshots to those object stores, which makes it a lot nicer to deploy Restate in these clouds. All right. Another, like the category of making operations a bit simpler is making memory management easier or automating it. So in order to get most out of Restate, you have to carefully tune your memory. And this has always been a bit tricky because you had to take into consideration how many partitions there are on a node. And actually, before 1.6, there was only this option, like you told Restate there are so many partitions, and Restate would distribute the available memory across these partitions. On a single node, that's fine, but on a multi-node deployment where the number of partitions can change. For example, if a node crashes, then some of the partitions will move to the alive nodes so that they run more partitions. You always had to plan conservatively here. So you always had to assume that the maximum number of partitions run on a single node in case all the other nodes crashed, for example. And so that for the normal case, you would always leave some of the memory unused. Now, this is also belongs to the past because Restate will automatically reconfigure the memory depending on how many partitions are running on a node. And that way you will make most of your available memory at any given point in time as Restate will adopt and adjust. We added also a few improvements, which made it actually possible to reduce the default memory configuration of Restate quite a bit, while maintaining the same level of performance. So instead of like giving 6 gigabyte of memory to RuxDB, by default it's now 2. Yeah, for the query engine we reduced it to 1 gigabyte from 4. One quality of life improvement is that when running on Linux or when running in Linux containers, Restate can detect if your C group limit and the RuxDB memory is misaligned, so that it can warn you that you might or should adjust your pod configuration, for example, or the Restate configuration. Okay, that was one, like, let's say, operational difficulty. Another operational difficulty was that we only had a single way to configure snapshots. Like, you could configure that after so many records, I want to create a snapshot. But in some situations, for example, if there's like a period of inactivity, this would mean that you wouldn't create any snapshots, or if the activity decreased quite a bit, your snapshot would be spaced out a lot farther. So instead, people were asking whether we could like have like time-based snapshots, which people usually prefer, because that way they can kind of bound the let's say time they have to replay in case of a crash. And now you can configure like the snapshot interval under the worker snapshots options, which tells you create me every n time units a snapshot. If you configure the snapshot interval too small, then with Restate 1.5 and before, you could easily end up with many snapshots on your S3 and now like Azure Blob Store and Google Cloud Storage, using up space, whereas only the latest snapshot was relevant for Restate to recover. So what people usually did is they manually added some cleanup scripts or used some lifecycle policies that the snapshots would be cleaned up eventually. But this was always a bit, let's say, tricky, because these lifecycle policies didn't know whether those snapshots were still needed or not. With 1.6, there's like an experimental feature that you can enable by setting the experimental num retained field under snapshots, which will instruct Restate to manage these snapshots. So to only keep the latest n snapshots and remove all others. And thereby, you will no longer accumulate a lot of snapshot state on S3 or so, making operations again simpler. Then we've reworked the deployment API to make CI/CD pipelines and general deployment operations more robust and less shooting yourself into your foot. So the biggest change is that the false flag is like when doing like deployment changes is no longer by default true, but now it's false. So you can't accidentally override a production deployment. Re-registering the same deployment is now idempotent, meaning it returns the 200 status code. And if you would like have a retry in your pipeline, it would no longer fail. There is now like a new breaking flag that you can pass to the deployment REST API to tell the system that you explicitly want to apply some breaking changes. For example, renaming a service handler or changing the I think the service type. And that is now like you should use the breaking flag if you want to do these kind of operations now. And it is now possible to update values of the deployment, like tokens or endpoints, without a full re-registration. There's now the patch endpoint the patch verb, which allows you to change deployment configuration if needed. And a nice little thing is if you use the GitHub actions workflows that we offer, then like it would automatically capture in the metadata of the deployments, like information about the repository, the commit, and the workflow info, so that you can link a deployment back to a specific commit in your repository. All right, those were the highlights. Now I want to spend like 2 more minutes on some of the, or making you aware of some of the breaking changes, so that if you upgrade, you know that some things you have to watch out for. The first thing is that we deprecated the deprecated SDK versions, like SDKs that are like below the specified version here, like invocation for these SDKs are now rejected. So you would see an RT20 runtime error when sending like an invocation to an endpoint that is still running Java SDK smaller than version 2, for example. This doesn't affect like already in-flight invocations, but you will no longer, the cluster will no longer accept those. So what this should tell you is, if possible, please update your SDKs, because this is a preparational step for deprecating some of these older or dropping support for these older SDKs. Then, as initially mentioned, the retry policy config option changed now. Like we dropped the worker.invoker.retry policy, and it's now fully replaced by the invocation.default retry policy. Also the default behavior, as I've mentioned before. Then the Helm chart resource defaults have been changed now from 3 GB to 8, and from 1 CPU to 6, to better align with the default values of Restate itself. Because before, if you used the defaults, it was so small that you could that the reset process, if given enough work, would have oomed the pod. If you want to keep the old values, you have to now explicitly set them in the values file. And last but not least, we corrected some of our Prometheus metric names. There were some like incorrectly named metrics that had like an incorrect count suffix, for example. So please check the release notes out for details in case you were using those metrics, and update the dashboards and alerts accordingly. And with that, we are 1 slide away from demo time. So hang on. So yeah, you get all these features by using the latest version. You can upgrade seamlessly without the need for manual migration. Just please remember, directly go from your 1.5 Restate version to 1.6.1. Skip 1.6.0 if you can. And yeah, for more information about what else has been changed in the release, follow or look at the release note. That's something that we started doing as of this version, or read the blog post. And the fast way, of course, to get started is using the Restate Cloud, where you already get the latest version if you start a comment there. And with that, I would like to hand over to Nik, I think, for the first demo.
Thanks, Till. Let me share my screen. Hello, everyone. Thanks for joining us today. And I hope everybody can see my screen. Perfect. So we are excited to show you some of the features Till was talking about in the UI, about the invocation control. So I'm running the Restate 1.6 in our Restate Cloud environment, and let's dive in. Let's go to the invocation tabs, and I can see there are a bunch of invocations that are paused. As Till mentioned, the default behavior is after maximum attempts, they will be paused. So let's go dive into one of them. And here I can see, let me zoom in a little bit so you guys can see. So in this instance, we are getting a token expire. So the pause happened after token expired error. It seems here we were doing a downstream call to an API that required a token, but that was and the token expires. Here we have a compact view, and you can also go to the detailed view. And this is the part that Till was mentioning, so you can also see the transient error that was happening. So apparently, for a period of time, we were getting the service unavailable error. And due to that error, the token that we got from the previous error now is expired, and now we are in this situation that we cannot make any progress. So our API, our invocation is always gonna fail. So I can resume this, like here, I can resume this, and it's gonna run, but obviously it's gonna still fail, and it's not gonna help. So I'm gonna pause this, and it's already paused. One thing that we can do here is we can kill the invocation, so we know that the invocation is not going to make any progress. And one of the features here is one of the paper cuts that we used to have, is if this dialog, confirmation dialog, is a pain, it's bothering you, so now you can say for the next time you don't need to ask me to confirm and just do the confirmation. So now the invocation is killed. Now we can restart the invocations. And as part of the invocation restart, we can actually say from which step to restart. So for example, here, in the first step, we were doing some heavy computation step. And I don't want to basically, in a new invocation, to repeat that steps. So I want to start to get the authentication token and just make my API call. And for the purpose of all demo, I'm going to register a new deployment that basically my service is going to pass. So bear with me. So I'm going to use the Cloud Tunnel here, and I'm going to register a new version of this deployment, localhost 1982, and hopefully this should go. Perfect. So I have a new version of this. So if I go back here to my invocation here, and if I do restart at new, so not only I can say, okay, start after the heavy computation step, I can also say, okay, use the latest deployment. Okay, so you can also say if there is an issue and you fixed it, then you can also say which deployment used to basically restart this invocation. So if I do this, hopefully this should run, and voila, my invocation passed, everything's successful. So this is one flaw of how it gives you flexibility to manage if any issue comes across basically the invocation that you are running to. Let's go back to the list of our invocations. Here I can see there are quite a bit of paused invocations. Okay, if I go to one of them, for instance, I can see there is a bad request happening. We are making some API call, and there is bad request. Probably there is a bug, and we like to fix that. Okay, I know that I just registered a new deployment, and for this purpose of this demo, I assume I fixed that bug in that new version of my service. And let's try to resume this to make sure. If I choose the latest one, let's say try that for this specific invocation and see if it's working. Perfect, it's successful. So we know we fixed that, okay? But now the issue is that all these invocation that is paused, okay? And now I can, go individually, select one, and then come here and say resume. But there is also a better way. You might in this instance, I have about 100 invocations, but you might have tens of thousands of invocations. So you can actually update your query here. And in the query, let's make the query, and then you can come here and say, okay, I want to resume all the invocations against this query. So my query is basically a specific service, and the deployment, I'm going to use the latest deployment, and I'm going to say, okay, resume. And this should basically resume all the invocations, and everything's successful. So it should help you with managing, dealing with a huge number of invocations. And as Till mentioned, you can cancel, you can pause, you can resume, you can kill. Just for the purpose of this demo, let's also purge all these invocations, just make it a bit cleaner. And this is how we can also do batch operations. Other than that, I think, yeah, that covers my demo. Happy to answer any questions if there is one. Then I will pass it to Pavel.
Maybe one, Nick.
Sure.
So resuming on the latest deployments, you kind of need to know that the steps before were the same, right?
Yeah.
Deployment. Yeah.
Yes.
Okay, cool. Thanks.
All right, let me take over. Thank you very much for that, Nick. That looks super useful. I'm looking forward to using some of those. I wanted to show you some of the new snapshot features that we've added in 1.6. So as Tom mentioned, we've added native support for the Azure Blob and Google Cloud Storage services that we can now run natively. I have here the command line to start Restate 161 server. While that's starting, I just want to show you what the configuration file looks like. So this is a server that I've already, as part of my environment, exported, because it's running on my machine, exported a path to the service principal key that I have on my machine. However, if we are running this Restate server in a container, for example, in GKE, then we'll automatically infer the pod principal based on where we are running. Now that we've done that, this is a brand new server. So what I will show you is it's pointing at this bucket. It's Google Storage Service bucket that's running near me. And we don't currently have any services deployed. So just start a watch command here, which is going to list the bucket. And I've already in another terminal started a lol test service that we often use. So let's deploy this, and I'm going to send some load at this Restate server. So this is going to start generating some traffic. And what we will see is that as we start getting traffic, we're going to start seeing some snapshots get created by the different partitions. So in just a little bit, here we have a snapshot for partition 0. There are only 4 partitions in this server configuration. I just wanted to make it very simple and easy to follow. But while that's going, let's keep the snapshots adding up. I want to draw your attention to a couple of things in the configuration. So we have set a very small number of records interval, just like historically we've had. The trouble with configuring snapshots to snapshot to trigger based on number of records is that if you have very large transitions in your services, if you send very large payloads, for example, this could actually, very few records could lead up to very large snapshot data accumulation. So now we have the option of combining a relatively small number of records interval with your desired snapshot interval. So we could use these things independently or both together. And when they're both used together, this means create a snapshot once every 30 seconds, as long as at least 100 records have been committed. So this gives you a way of ensuring that
snapshots will happen, however, during periods of no activity, we're not going to be generating excessive usage on the object store. And now we should be able to see that in this bucket, after some time has passed, we have, although multiple snapshots have been generated and recorded. This is wrapping funny. Let's try and list this thing again. We can see that we actually have just 2 different snapshots. And these 2 different snapshots are actually a moving target. And the reason why we only have 2, and these snapshots will be deleted over time, is that we have configured the new experimental feature for snapshot pruning, and we have capped the number of retained snapshots at 2. Just bear in mind, if you do activate this feature, historic snapshots created before this feature was first used are not going to be managed by Restate. So only once you activate the feature, new snapshots created from that point onwards will be tracked by Restate for the purposes of pruning. Hope that makes sense. I think that is it for the demo of snapshots. But what I also wanted to very briefly mention is a couple of improvements on the documentation side. If you have a question, please just speak up.
Sorry, that was a misclick.
Oh, no worries. I also wanted to show you that we have made some improvements to the snapshots documentation. So traditionally, this area had been a little bit obscure. We've now got a lot better guidance on how to configure automatic snapshotting, how to think about the frequency with which you may want to take snapshots, and just bear in mind snapshots are not backups. This page also talks about backups, and it talks about retention. While I have your attention, just wanted to mention we've also released a new version of the Restate CDK toolkit. If you're deploying to Lambda, this is very commonly used. This now supports, it has caught up to the Restate operator in that it supports pruning your drained deployments. So one of the really nice features about deploying to Lambda is that you can cheaply create multiple versions and you can just retain lots of old versions on Lambda. However, historically, we never pruned those deployed older versions from Restate. And that could lead to accumulation of, firstly, when you do Restate deployments list, you would see a whole bunch of endpoints that you probably don't care about, but it also pollutes your metadata store with additional deployment information. So this is now there. We also support the new backwards compatible breaking changes deployment in Restate deployments. And then finally, I want to give you a sneak peek of another new feature that we have coming. So this is more of a Restate Cloud. I know today is about the Restate 1.6 release. But recently, we've been adding some new security and enterprise-friendly features to Restate Cloud. We now have a new identity provider where we support corporate SSO. And in this case, you'll see the new Restate sign-in UI, which of course now my password manager has locked just in time for the demonstration. But I will unlock it off screen. So I'm going to sign in with this fictitious user. This is our dev environment, by the way, and I'm deliberately there to show you something that is not yet in production. So we are going to say continue with SSO. If you have a corporate domain registered with Restate Cloud, this will bounce you over to your corporate identity provider. That was Okta, where I've already signed in, so we've been automatically directed back to Restate Cloud. The other exciting new feature that will be offered on enterprise Restate Cloud customers is that once you onboard with a single sign-on, we now support corporate directories and role-based access control. This will be soon rolling out to production. And what this allows us to do is create organizational administrative roles based on corporate directory attributes. And these Restate organization users will additionally have the ability to manage permissions. So you will then be able to list all enumerate the users that come from your corporate directory, and you'll be able to assign them individual access. So this is going to give you a lot more flexibility for managing shared environments that need to be aimed at specific stages of your deployment or teams or different product configurations that make sense in your environment. That is all for the demo.